Okay, we are going to be looking at this series circuit today, and we are going to do the analysis of it. So the first thing that you do is you look for the total resistance. Total resistance is equal, in this case, we have two resistors, so it will be resistor 1 plus resistor 2. If there are more, you would add them, okay? So 220 ohms plus 470 ohms. All right. With this, pretty easy to see that that is going to be, we already know that it's in ohms, 0, 9, 6, 690 ohms. So I'm going to go over here into a reporting area just to put everything that I need to report. And I'm going to write 690 ohms. It is already in two significant figures because 1, 2. We are good. The next step is to find the total current. So that is I sub T. To find the total current, we are going to use current is equal to voltage divided by resistance. Okay, the total resistance. All right. And so when we do that, we have the voltage. I'm going to go over to this side so that we have room for everything else. The voltage is 12 volts. And divided by this number right here, the 690 ohms. Okay, and so we get our handy dandy calculator, and 12 divided by 690, we end up with 0.017, and I'm going to write out the whole thing here, 0.017391304 amps. Now, because I've asked for this to be in significant figures, okay, I look. Here, 0 is not a significant figure because we haven't hit a whole number yet. Okay, so 1, 2 significant figures. So this is where I look to this number and I say, is this number 5 or higher? No. So all of this information does not get reported in our answer. Okay, but we will use that throughout the rest of the problem, okay, because we have to use our fully calculated number. All right, now because this is a series circuit, that means that current stays the same throughout the entire circuit because it goes through one path, all right, and voltage will change at each resistor. So the next thing that we want to do is we want to find the voltage at resistor 1. And that formula is voltage at resistor 1 times total current, or is equal to total current times resistor 1. Okay, so we're going to put this information, okay, it's right here in our calculator, so why not just hit second answer, right? Okay, so that answer, and it's going to be times, so I'm going to go over here and I'm just going to put IT, knowing that that goes there, okay, times the 220. All right, so we multiply it by 220, okay, and that right there is going to give us 3.826 0.08657 volts. Now, because we want to do this in two significant figures, this is our first significant figure, this is our second significant figure. Is that number higher, or 5 or higher? No. So voltage at resistor 1 is equal to 3.8 volts. Okay. Next, we want to find the voltage at resistor 2. And that, of course, again, is going to be your total current times resistor 2. So I'm going to write IT over here again, okay, knowing that it's this number up here, and put 470 ohms. All right, so down here, you want to make sure that you have the full number, because if you use a rounded number, you may not get the right answer. Okay, you'll get close to it, but not the actual right answer. So this gives us 8.173913021 volts. Two significant digits, 1, 2. Okay, is that number equal to or higher than 5? Yes, it is. So that means this 1 becomes a 2. So voltage at resistor 2 is equal to 8.2 volts. Now, if we would like to verify using Kirchhoff's voltage law, okay, what we are going to do is we add what KVL tells us, that the total voltage is equal to the voltage at each resistor, the sum of the voltage at each resistor. So our total voltage was 12 volts, and we are wondering, does 3.8 volts plus 8.2 volts, does that equal that? Why, yes, it does. So that checks out. So that is how we do the circuit analysis for a basic series circuit.